Hello everyone, and welcome to our very first lesson of Chapter 7. This is our introduction to polygons. And we discussed in class how the root word poly means many, and so we're going to be talking about things that have many sides. Polygons means many sides, multiple sides. And the first thing we did is we color-coded this picture. And we talked about how we already know what many of these names are, but this was just a refresher from middle school. So if you need to pause this video and go ahead and fill this in on your notes, you can. A three-sided figure was a triangle. Of course, that root word tri meaning three. A four-sided figure is generally a quadrilateral. So not necessarily just a square. A square is a specific type of quadrilateral, but any four-sided figure is called a quadrilateral. Five-sided figure in Washington, D.C. is the pentagon. It is a five-sided structure. And hexagon is six. So there's two H's. There's a hexagon and a heptagon. The way I used to remember that hexagon went with six is because six has an X in it, and so does hexagon. Okay. Seven-sided figure is a heptagon. An eight-sided figure, think of an octopus. It has 8 legs. That is an octagon. Nine-sided is nonagon. 10-sided is decagon. Think there are 10 years in a decade, so that one's easy to remember. An 11-sided figure does have a specific name. I think it's called a hendecagon, but in our book, we generally just call it an 11gon, and then a 12-sided figure is a dodecagon. So anything other than that, if you're just talking about like a general number of sides, like if it's like 15, you just call it a 15gon. So I'm going to say if an n number of sides would be an n-gon. Okay, so like that could stand for 100 or 100gon. And so what we did today is we looked at this little demonstration. Let me pull it up for you real quick. And we started with the sum of interior angles. And what we did is we broke these shapes down into triangles. So this is already a triangle. There's one triangle. It's 180 degrees. So when we went to the square, if you were to draw on a diagonal, that would be 2 triangles. So we'd change this number to 2. And you'll see that gives us a yes. There are 2 triangles in there. And then that would give us 180 degrees plus 180 degrees would give us 360. And so yes, there are 360 degrees on the interior angles of this quadrilateral. We changed it to 3, or a 5-sided figure, which gave us 3 triangles. We just played around with this in class, and that would give me 540 if there are 3 triangles. So you can play around with this. You can keep going up on the scale. But what I'm going to do now is to kind of demonstrate how we drew those into our triangles on the back. So go ahead and flip it over for me if you're watching this video. And we're going to talk about the relationship for where this formula comes from for triangle angle sum. So in this triangle right here, this triangle has 3 sides. It's 3 sides, and it contains 1 triangle. That 1 triangle is going to be 180 degrees on the interior. So the interior angle sum is 180. Okay? When we went to a quadrilateral, this one is a square, but when we went to a quadrilateral, this is a 4-sided figure, 4 sides. If I draw in from a vertex, I draw in the diagonal of this shape, then I have 180 degrees in this triangle and 180 degrees in this triangle. So in these 2 triangles, 2 times 180 is going to give me 360 degrees. 360 is my amount, because that was 2 times 180. Okay, and we just kept going through this pattern. This is a 5-sided figure. It has 5 sides. So when you pick a vertex and you draw in the pieces to each other vertex, we have this. Obviously, this is not going to be a vertex right here because that is side length, so that does not count. So when you draw in these diagonals, you get 180 degrees in each of these triangles. So how many do we have? We have a total of 3. So 3 triangles, 3 times 180 gives me 540 degrees. So we kept going up, and we just kept seeing what changed every single time. And you'll see that we're just adding an additional triangle each time. Okay, so I'm going to do that here. This would be 6 sides. In the 6 sides, there would be another triangle, so there would be 4 triangles. I'm going to show you that, and I'm probably going to stop drawing them after that. We'd have a diagonal here, and so we'd have 4 of those triangles. So 4 times 180 is going to give me 720 degrees for this interior angle sum of hexagons. And then we kind of paused. We played around with this in class a little bit, but you notice the number of sides is going up 1 every time, and the number of triangles is going up 1 every time. But I wanted to see if people could catch on to the relationship between the number of sides and the number of triangles. So like 3 and 1, 4 and 2, 5 and 3, 6 and 4. And many of you caught on rather quickly that those are always a difference of 2. There's always a difference of 2. So in a 7-sided figure, before I even draw it in, if there's 7 sides, there are going to be 5 triangles. The difference of 7 and 2 gives me 5. So there'd be 5 triangles. So 5 times 180 would give me a sum of 900 degrees. Okay? So that means that an octagon is going to be an 8-sided figure, obviously. So how many triangles would be created when I draw those in? There would be 2 less, so that's going to be 6 triangles. 6 times 180 is going to give me 1080, 1080 degrees. Okay? So we kept going through, we filled this in just so that students could see where this comes from. A nonagon is going to have 9 sides, so it's going to have 2 less triangles. You can kind of see that when you draw it in. 1, 2, 3, 4, 5, 6, 7 of those diagonals. Oh, nope. There we go. And so 180, 180, 180, 180, 180, 180, and 180. I have a total of 7 triangles. And you can see when I draw those in, I don't include this piece, and I don't include this piece like I just tried to do, because those 2 are already the sides of the triangles. Those are not the diagonals, because that's going to a vertex next to it, and so that is not going to be included. Okay? And so what is 7 times 180? What would be my angle sum? 7 times 180 is going to give me, I want to make sure I did this right, 1260. That's the one I don't have memorized as well. So that's going to give me 1260 degrees here. And so decagon is going to be 10 sides. 10 sides would give me 8 triangles. And so 8 times 180 is going to give me 1440 for my angle sum. And then dodecagon, it skips ahead to 12. It doesn't include the 11. It's just not pictured. So 12 sides is going to give me 10 triangles. This one's a very pretty number to work with. 10 times 180 is 1800. So you would be able to create these shapes and create this formula, even if you didn't know the formula by heart. You'd be able to create a list here and just say, hey, I'm just adding 180 every time. So a triangle had an interior angle sum of 180. A quadrilateral is going to be 180 degrees more than that. So I'm going to add 180, and that's 360, and we just keep adding 180 every single time. Okay? So let's see, to be plus 180 again would be 540. And so this is how we came up with all of these numbers. We saw this come to life. 900, 1080, 1260, 1440. Now an 11gon, how many triangles would there be on the inside of an 11gon? There would be 2 less, so 11 minus 2 is 9. 9 times 180 gives me 1620. And then this one was our pretty number, 1800. So there is a formula for the interior angle sum, instead of you having to make this chart every time. Because I don't know about you, but if I had to find the number of the interior angle sum of a 30gon, I would not want to have to make this chart. So here is my formula. This is for any polygon n, okay? For any polygon n, to find the interior angle sum, you're going to do the number of sides minus 2 times 180 degrees, okay? N minus 2 is going to give you your number of triangles. So that's our number of triangles. Or I'm sorry, not number of triangles, our number of sides. N minus 2 gives you your number of triangles. So like if you have a 10-sided figure, 10 minus 2 would give you 8, which would be 8 triangles total. So N minus 2 times 180 gives me any general number of interior angle sums. So like let's say that you had a 30-sided figure and you wanted to figure out what is the interior angle sum of this 30-sided figure. You'd do 30 minus 2 is 28, and then times 180 would give me 5,040 degrees. So that is for the interior angle sum.